Welcome back to the R Primer tutorial. I'm Ty Taylor from the Operator's Manual for the Planet, and this is a tutorial to get you up and running in programming for data analysis in R. This is a video in a series of videos for this tutorial. You can find the whole playlist of videos in the notes below this video on YouTube. In those notes, there's also a link to a Google Drive folder, which contains the tutorial files that we're using here. So if you want, you can download and open up the R tutorial with blank in the title, and then all you have to do is type what I type as I type it. The easiest way is going to be for you to put this YouTube video on an external monitor or on your TV or on your phone even, because what you're going to do is just watch me on the video and then you type in whatever you see me typing into your own computer. So you'll need two screens to do this, okay? You can go into YouTube and click the gear icon, go to playback speed, and you can change the speed of this video to 0.75, 0.5 even, or 1.5, 2x. Sweet. So we have gone through a lot of ground so far. We've gone all the way through objects, vectors, functions, matrices, data frames, and finally we are going to get to importing data. That's what you want to do to analyze your own data. We're going to import a data set as a spreadsheet so that we can interact with that as a data frame in R. To analyze your own data in R, the most common kind of data that you're going to want to pull into R is a spreadsheet-like data set. And the most common file format for that is a .csv, or comma-separated values. You can make that kind of file with just taking a typical Excel file and just save as a CSV. I'll show you what that looks like. But just a couple of pointers first. So this part, calling in your data, we often end up spending the most time in the classes when I teach this tutorial just getting people's data pulled into R, because there are a few little tricks that you have to know or it won't work. But once you learn those tricks, it's going to be easy and it won't be something that gives you troubles in the future. Okay, so first your spreadsheet has to be prepared for R. So your data sets need to be very clean and tidy. So you have to get used to meticulously cleaning up your data sets, not manually editing cell values. I'm not talking that kind of cleaning, but just making the data set the kind of format that can be pulled into R. So what kind of format is that? It should have a single header row with simple column names, and it needs to be one contiguous data set. Let's look at an example. So if we go to the glopnet CSV, these are the tutorial files that you may have downloaded from the start of this tutorial. If not, and you're just joining us again after a break, remember that in the notes below this video, there's a link to the Google Drive folder that has these tutorial files. You can download those, save them in a folder on your computer. After unzipping the folder, do not work within the zipped folder. Unzip the folder, save them in a folder on your computer, not on your desktop, not in your downloads. Okay. So now, if you have glopnet.csv here in a folder, let's open that up and see what it looks like. This is a published data set of global plant traits. And I've already cleaned up this data set a bit from its original Excel version. Here are a couple of typical features of Excel files that you need to get rid of. Lots of junk up above the data set in rows of notes. So Excel files will often have like several rows of just notes before you get to the header. You need to eliminate that. That is junk. Okay, so delete all of those extra rows. Make sure you only have one header row, and that header row should have simple column names. don't include spaces. Instead, use dot or underscore separators, and no special characters like accents, etc. In fact, those shouldn't occur anywhere in your data set. R can have trouble reading special characters. And your data set must be contiguous. That means you must have a single rectangular data set with no big gaps between top or bottom. For example, people's Excel files often look like this. There will be one data set over here, and then they made like a subsetted different data set over here, and you have this one file with all these actually different data sets within it. You need to get rid of all of that, close all of the gaps, pick only one data set to have that you want to download into R. It should have a first column, and you should be able to go to the last column, and there should be nothing else beyond that. Go also to the bottom of your data and make sure that there is no extra junk down here. See how there's all this empty space, and then I've just got these notes, or, people often put like the sum of, this, they'll have like sums of columns, like this whole column, right? And it'll be like total, and then they'll have maybe one that's like a mean. So get rid of all this junk, but it's not enough to just delete it like that, because Excel remembers that these are cells that now just have empty space. And when R pulls that in, you'll get all these rows with emptiness or with NAs in them. So select all of the rows that might have had junk in them and right-click and delete those rows. That completely eliminates those rows from the file. So now R will see this row as the last one in the file. Okay, I show you some more detailed examples of that in the Getting to Know R and RStudio tutorial. So if you want to work through that more carefully and go from an Excel file to a CSV, you can follow that tutorial. I'll just quickly show you, if you are in an Excel file and you've just cleaned up your data set and you want to turn it into a CSV, go File, Save As, and just select here in the file format, comma-separated values. Normally, it'll be an Excel workbook like .xlsx. Save it as a .csv. Okay, so now we have our cleaned data set. We have a .csv version of it that is nice and simple, and we want to pull that into R. Now, the next thing that we have to do is point R to that file. So, one way to point R to the file is by using this thing called the working directory, and let's just show you by example. So the easiest way to set the working directory is this way. Go to Session at the drop-down menu at the top of RStudio, set working directory to source file location. Click that, and you'll see that a line of code appeared here at the bottom. Now, if you want to incorporate that in your code, you can, for example, right here under 8-1.2, just copy that code into your R script. And this code will set the working directory to the location containing this script. That's the source file, is this script. So you see how it set it to Documents R Tutorials T1 R Primer. That's the folder here, Documents T1 R Primer, that contains this script that we're working in. And then that folder contains the glopnet.csv dataset. So now R knows where to look. If you want to call in data, it will just go to this folder because you've set that as your working directory. Obviously, you can also set a different working directory. If you want to, you can use this command and you can change this file path to a different working directory. Okay, we've got our working directory. R is now knows where to look when we tell it to call stuff in. So now let's try reading in a file as a data frame. So we have glopnet.csv in the right place. It's in the working directory. Last thing to make sure that you check, this often trips people up in classes that I teach, is you want glopnet to be named perfectly. So if you've downloaded glopnet like 5 times because you got confused and you don't know where the files are going, then you'll end up with this parentheses and a number because you've downloaded the same file multiple times. If we try to call glopnet.csv, it won't find it because this is glopnet5.csv. So we need to make sure that glopnet is named correctly, glopnet.csv. Now, our file's in the right place, it's named correctly. Let's call it in with read.table. Take a look at the read.table help. So read.table. We are in 8-2.1 right now. So read.table takes as its first function, as its first argument, the argument file, and then it has, it asks you, does the file have a header? Its default is false. What is the separator for the file? Ours is actually comma. Its default is empty space. And then a bunch of other details that you usually don't have to worry much about. Okay, we'll close that up and let's try reading in our file. So we need to give it a name. And just like before, we've created objects using the arrow. And when I say is, you know, that's arrow. So we're going to call this one glop. So I'm typing glop is. And now we're going to read in the file, and it's going to point that file to this name glop. So we'll have an object glop that contains that whole data set. Okay, so glop is read.table, open parentheses, file, that's our first argument, equals, quote, glopnet.csv, get out of your quote, comma, space, sep equals, comma, so quote, comma, that's the separator in this file because it's a comma separated file.csv. And then we'll say header equals t because there is a header row. That first row will contain the column names for our file. And then I always add this argument as.is equals t. That just stops R from converting character columns, so columns with text, into factors, which are really annoying to work with. So I always recommend using as.is equals t. Okay, execute that. And now let's take a look at glop. It's a big data set, so I just printed the entire glop down at the bottom, and it said it reached the max of max print because the R console will only show you so much data before it, decides that it's not really worth showing you the rest of it because you can't even look at it very well that way. I'm going to show you in the next section how to get information from larger data sets and how to view them in different ways. For now, though, you have had a lot of practice with head, so down here in the console we can type head glop, and then we can see a little bit more easily what glop looks like. Now let's try a different version of a function to call in your data. This one is a bit simpler, and it's a nice shortcut for .csv files. So this is read.csv. So let's take a look at the help for read.csv. Oops. Okay, the read.csv takes you to the same help page as the read.table. But if you just scroll down a bit, you see the read.csv because there's lots of kind of versions of read. And it puts them all in one help file. So the first argument, similar to read.table, is file, and then the default for the header is true, whereas in read.table it was false. Separator is a comma as the default, and those are the argument values that we typically want for reading in a .csv file. So then we don't have to specify as many arguments. It's shorter code, which is always nicer. So let's say this time glop is read.csv, open parentheses, file equals glocknet.csv in quotes. Remember, you can use single or double quotes. They are the same. So I can also go double quotes just like that. It doesn't matter. And then we're just going to add the argument as.is equals t to avoid character columns being turned into factors. We haven't talked much about factors yet, except for me to say that they're a bit annoying. We'll get into those in the next tutorial. If you found this video useful so far, by the way, please give it a like with that little like button at the bottom of the video. Subscribe to the channel for more like this and for some cool scientific adventures. I do work in the Brazilian Amazon there. And if you'd like to be the first to know about new tutorial videos dropped on YouTube, or you'd be interested in an online course where I can take you all the way from the most basics of R up to advanced custom functions and iterations, then send me an email at earth.operations.r@gmail.com. Sweet. Okay, so again, look at the head of glop. I just typed that down in the console. It's the same thing. It looks exactly the same as when we called it in by read.table. There is a much better way, in my opinion, of calling in files better than setting the working directory. The working directory is really constraining. It constrains you to working all within one folder. So then, like, your scripts are in the folder, your data sets are in the same folder, all of your figures get outputted to that same folder. That just makes your folder a mess. And I am a big proponent of careful, good file management. It makes your life a lot easier. And if you want to use better file management and have different folders, then let's use this method. So don't be tied to one working directory. Let's use multiple folders. You can have, for example, a folder for scripts, a different folder for data, a different folder for figures, etc., etc. So we can easily point to these different folders using directory objects. I'm going to go here to my Finder, and then I'm in my tutorial folder here, and on the Mac, I can just go to the bottom of the Finder window and right-click and say copy T1 primer as path name. If I copy that, then I'm going to save it to an object here. I'm going to call it t1.dir for the tutorial1 directory. And that is, quote, paste. And the last thing that I need to do to be able to use this to call files is end that with a /. I'm in Windows now, and to copy a file path or a directory path in Windows, you can go into your Finder like this and go up to the address bar where it's in Documents, R Tutorials, T1 R Primer. I'll right-click that folder and type copy address as text. So I can copy that, and I can come into my script, open quotation marks, and say Control V to paste that into my script. And now remember that you're going to have to turn all of these backslashes forward. One fast way to do that is to go to highlight that line and go to Control F, and then make sure to check in selection, delete everything in that find box, and then just paste a backslash over here and then a / here. Make sure that this line is still highlighted and that you have this in selection box checked. And if so, then you can hit the button all and it will replace the / in that highlighted area. Now R can read that to call in files. Make sure though that you have that area highlighted and you're doing in selection. Otherwise, all of the slashes will be changed in your whole script. Okay, so we have a t1.dir. Let's use this to read in glopnet.csv. So we're going to say glop is read.csv. And now instead of just file equals glopnet.csv, like we did before, in fact, here, let's just finish this out. So then all we want to do is add the as is equals true. So that's the read.csv that we used before. But now instead of relying on the working directory, we're going to give it the entire file path name. And we'll do that by using paste, which you've already practiced with before. We're going to say file equals paste, open parentheses, make sure it gets closed after glopnet.csv. So glopnet.csv right now, should be enclosed in parentheses on either end. Now in front of glopnet.csv, type t1.dir, comma, and now it's going to paste the directory and the file name together. If you just highlight that part of the code and hit Command Enter, Control Enter. Oops, I need to create my t1.dir. Right. There's a shortcut. So you see how paste added a space in between the directory and the file name. So we need to use this little shortcut. You could either say sep equals ... so an empty space. Remember we did that before. You can have different separators when you're putting together your two text strings. Or we can use this shortcut, which is paste 0. Paste 0's default separator is no space. So I'm going to highlight paste 0, t1.dir, glopnet.csv. And if I execute that, it shows us now this complete file path at the bottom. And you can see it goes right from the last folder. It has the /. That's why we needed to add that / here at the end of our directory object, so that it knows that this is the end of the folder name and the / gets us inside the folder. And then this is the file name, glopnet.csv. Okay, execute that, and glop is the same as it has been. So we've achieved the same result. But let's add a little bit of flexibility so you can see why you might want to do this. We're going to make a directory that just ends at R tutorials. So let's just cut out all of that part. Actually, I'll just cut it. So I'll use Command X, Control X. I'm going to say toot.dir for tutorials directory is inside of quotes. And I'm going to give the path just to R tutorials. So that'll be a path to here, to R tutorials inside here. And now I could do something useful, like create a datasets folder. And then we could move our glopnet into datasets, put my data there, and then I can say dat.dir is paste 0, tutorial.dir, datasets. And now I can point to my datasets folder, and we could use that from any of our tutorials. If I have that, then I would just change this to dap.dir if I was going to put glopnet in that datasets folder. Okay, so note that using full directory file paths in the call to the file argument, it just bypasses the working directory. So you don't ever need to set the working directory if you use this method. Okay, now you know how to call in your files finally into R as data frames. Let's finally take a look at how to get info from bigger data frames. Then we'll talk just shortly about packages and give you a couple of troubleshooting exercises, and that will be the end of the R primer. Then if you want to move on from this primer and become an R ninja, check out my next tutorial. And also you can email me if you want to know when new tutorials drop on YouTube, or when I've got an online course and you'd like a link to sign up. You can email me at earth.operations.r@gmail.com. So there's a few simple functions. Now that we have our GlopNet dataset pulled in from that previous section, there's a few ways that we can look at that dataset in R. One of them is by using this manual point and click step here. So remember that in the upper right window of R, we have this environment tab. And if you scroll through that environment tab, you'll eventually find where we called in glop, or you'll find the object glop listed there. Just click on the name glop and it will show you in this new tab. R has then opened up a new tab between the other scripts. It's kind of like a script tab, and it's showing you this data set more in like the same way that you would see it if you were to open it in Excel. Okay, so that's one way to take a look at it. I just closed that tab up there. You can also get to you can access that same function by using view. You saw when I clicked on glop there, it executed the code that created that new script tab. So you can also just type that code, view glop, which I'm doing down here in the console, and hit enter, and it will open up your data set like a spreadsheet. You can't edit it in there, you can only view it. Okay, so yeah, that was here, view glop. Now in 9-1.1, so here's some other functions for getting information from your big data sets. We can use the structure function, str, glop. We showed that earlier with some of our simple data frames. This is really useful for big data frames. So it shows you that glop is a data frame. It has 2,548 observations or rows of 23 variables or columns. And then it shows you what is the class of each column, integer, character, and it shows you the first few entries from each column. So this just gives you kind of an overview of what does this data set look like. Head, of course, we've used a lot, so let's look at head glop. It's great to get in practice. I just use head like constantly because anytime I make an alteration to a data frame, usually I want to check to make sure that that alteration worked like I thought it did. And I just like to see a bit of the data frame just so I'd kind of, it's easier, instead of just imagining the data while you're coding away, it's easier to just take a look at a little representation of it. So look at the head of your data frame like that. You can also look at the tail or the last few rows of your data frame with tail glop, and that shows you the end. This is a good way to check if your data set has been called in correctly, because if you look at the tail and you just see all NAs or all like empty spaces, then it's probably because you need to delete a bunch of rows in your CSV file that previously contained data or junk at the bottom of your data set. So you need to delete those rows so that all those extra rows are just permanently gone and your file actually ends at the last row of data. Okay, names. Glop, that returns a list of your column names, actually a vector of your column names. Names is the same as call names we used earlier. So if I go call names, glop, usually for data frames, because names returns the same thing as call names and it's shorter, I use names. Unique returns the unique entries in an object. So let's look, for example, at what are the unique data sets in glopnet. So I just did in 9-1.5 unique glop $ data set, and we get a vector of all of the different data sets that are included or that are the sources of the data from the glopnet database. Length returns the number of elements in an object. So for example, let's see how many different data sets there are that make up the glopnet database. So we'll say length unique glop data set. So I basically just put that previous line inside of a call to length. And we can see that there are 175 different data sets as sources of data in glopnet. And don't forget these other useful ones that we showed you earlier in this tutorial. So we have summary glop. Then there's nrow to see the number of rows in glop. And then ncol to see the number of columns in glop. And those are a few of the tricks to be able to look at your data frames. Working in R with data frames is not like working in Excel, where you're always going to just be looking at the whole thing and pointing and clicking on stuff. There's an art to working with data in R, which is you have to use a little bit more of your imagination, but you can, as I've just showed you, use several tools to look at the data set, and then instead of trying to scroll through it like you would in Excel and point and click on things, you instead use logical tests. You use code to interact with your data and to get information about it. I'm going to end this video here, but if you want to continue on with the tutorial, just find the next video in the series. There's a link to the whole playlist of my R tutorials in the notes below this video. If you found these tutorials useful, please give the video a thumbs up, consider subscribing, and let me know in the comments below what you found most useful from this tutorial and what you found most confusing. That'll help me to make better tutorials in the future, and it'll help other people to find these and benefit from them like you have. And if you'd like to be the first to know when my next tutorials drop on YouTube, or when I have an online course offering and you'd like a link to be able to sign up, send me an email at earth.operations.r@gmail.com, and I will let you know when anything new in the R tutorials world happens. Thank you so much for joining me. I'm Ty Taylor from the Operator's Manual for the Planet, and I will see you in the next tutorial. Peace.